The circular economy is a model that aims to keep resources in use for as long as possible, minimizing waste and pollution. It focuses on closed-loop systems where resources are continuously reused, repaired, and recycled rather than discarded. The goal is to maximize resource efficiency by reducing consumption and environmental impact. Regenerative practices that restore and replenish natural systems are a key part of the circular economy. Maintaining the value of products and materials throughout their life cycle is crucial to the circular economy. The circular economy is a model that aims to keep resources in use for as long as possible, minimizing waste and pollution. It focuses on closed-loop systems where resources are continuously reused, repaired, and recycled rather than discarded. The goal is to maximize resource efficiency by reducing consumption and environmental impact. Regenerative practices that restore and replenish natural systems are a key part of the circular economy. Maintaining the value of products and materials throughout their life cycle is crucial to the circular economy. The linear economy is a model of production and consumption that relies on extracting resources, manufacturing products, using them and then discarding them as waste. This approach leads to a number of serious issues, including depletion of natural resources, greenhouse gas emissions, waste generation and pollution, and loss of biodiversity. In contrast, the circular economy aims to address the limitations of the linear model by designing products and systems that minimize waste, maximize resource efficiency, and promote sustainability. The circular economy is a closed-loop system where resources are kept in use for as long as possible through strategies like resource conservation, waste reduction, enhanced recycling, and sustainable production and consumption. Transitioning from a linear to a circular economy is crucial for addressing the environmental challenges we face and ensuring a more sustainable future. There are various key moments in the history of the circular economy, from the 1970s to the present day. In the 1970s, early environmental awareness and concerns about resource depletion led to the development of recycling programs and waste reduction efforts. In the 1990s, sustainable development and the concept of industrial ecology gained more attention and traction. In the 2000s, the circular economy concept became more widely recognized, with the publication of influential reports and the development of circular economy frameworks. From the 2010s to the present, we've seen rapid growth in circular economy initiatives, driven by factors like resource scarcity, climate change, and increasing consumer demand for sustainable products. This slide provides a high-level overview of the evolution of the circular economy over the past few decades, setting the stage for the rest of the presentation. The circular economy is a sustainable model that aims to minimize waste and maximize the use of resources. Key principles include reducing, reusing, and recycling materials to conserve resources and minimize waste. Designing products for durability, repairability, and longevity extends their lifespan and reduces the need for replacements. Closed-loop systems continuously reuse and recycle materials, preventing waste from entering the environment. We can learn from natural systems and apply biomimicry and regenerative agriculture to develop sustainable practices. These principles work together to create a more sustainable circular economy that is better for the environment. The image on this slide provides a visual representation of the circular economy, highlighting the closed-loop nature of resource utilization. The title "Reducing Waste and Maximizing Resource Utilization" sets the stage for the key themes of this presentation. The first statistic, 80% waste reduction, emphasizes the importance of circular economy strategies in reducing waste generation through reuse, repair, and recycling. The second statistic, 90% resource efficiency, underscores the significant environmental benefits that can be achieved by optimizing material usage and extending product life cycles. These statistics and the accompanying explanations demonstrate the substantial impact that businesses can have by embracing circular economy principles. Designing products with circularity in mind is crucial for reducing waste and environmental impact. The key principles are reducing material use, extending product lifespan, promoting reuse and repurposing, and facilitating recycling. By optimizing product design, we can minimize material consumption without compromising functionality or performance. Creating durable, reparable, and upgradable products helps extend their useful life and reduces the need for replacements. Designing products that can be easily disassembled, refurbished, or repurposed for other applications promotes reuse and extends the life of materials. Using materials that can be easily sorted and recycled at the end of a product's life simplifies the recycling process and enables more effective material recovery. Renewable and restorative materials are a key focus for sustainable product design and manufacturing. These materials come from natural, plant-based, or recycled sources, offering eco-friendly alternatives to traditional materials. Bio-based materials like wood, bamboo, and cotton are derived directly from nature and can be regrown or composted, making them a renewable resource. Recycled materials repurpose waste products like paper, plastic, and aluminum, giving them new life and reducing the need for virgin materials. Geopolymers made from industrial byproducts provide a sustainable alternative to traditional concrete, reducing waste and the environmental impact of construction. Mycelium-based materials grown from fungi are lightweight, biodegradable, and have insulating properties, making them a versatile sustainable option. All of these renewable and restorative materials help reduce waste, conserve natural resources, and minimize the environmental impact of products throughout their life cycle. Extending the lifespan of products is crucial for sustainability and reducing waste. We'll explore 4 key strategies for extending product life cycles: repair, refurbishment, remanufacturing, and recycling. Repair involves fixing damaged or malfunctioning products to restore their functionality. Refurbishment is the process of restoring used products to like-new condition, often through cleaning, repainting, and replacing parts. Remanufacturing goes a step further by disassembling products and rebuilding them with new parts, significantly extending their lifespan and reducing waste. Recycling involves processing used products to recover valuable materials that can be reused in new products. The graphic on this slide illustrates the circular economy concept, showing how products can be reused, repaired, refurbished, and remanufactured to extend their life cycle and reduce waste. Reuse involves giving products a new life without any modifications, which extends the product's useful life and reduces waste. Repair is about fixing damaged or malfunctioning products to restore functionality and prevent premature disposal. Refurbishment is the process of restoring used products to like-new condition, often involving cleaning, repainting, and replacing parts. Remanufacturing takes products apart and rebuilds them with new parts, creating a new product with a longer lifespan. These circular economy principles are key to creating a more sustainable future by keeping products and materials in use for as long as possible. The sharing economy and product-as-a-service models are transforming how we access and use products. These models provide access to goods and services without the need for individual ownership. Let's look at some examples of how this is playing out in different industries. Car sharing allows people to access vehicles on demand, reducing the need for car ownership and promoting more sustainable transportation. Bike sharing systems make it convenient and affordable to get around, reducing traffic congestion and encouraging active transportation. Clothing rental services let people rent clothes instead of buying them, reducing textile waste and promoting more sustainable fashion choices. Tool libraries enable community members to share tools, reducing the need for individual purchases and promoting resource sharing. These models are part of a broader shift towards a more circular and collaborative economy, with significant environmental and social benefits. Circular business models are a key part of the transition to a more sustainable economy. They involve rethinking traditional linear take-make-waste models and instead designing products and services for reuse, sharing, and regeneration. Let's explore 5 key circular business model approaches. Product as a service. Companies provide access to a service rather than selling a product. This incentivizes them to design for durability and reuse. Closed-loop manufacturing. Products are designed and manufactured with reuse and recycling in mind from the start. Sharing economy. Enabling the sharing of resources like cars or tools to reduce individual ownership and waste. Industrial symbiosis. Companies collaborating to share resources and byproducts, creating a more circular flow of materials. Regenerative agriculture. Restoring soil health and biodiversity to enable sustainable food production. The linear supply chain is the traditional model where materials are extracted, produced, consumed, and then disposed of or sent to landfill. This is a wasteful and unsustainable approach. In contrast, the closed-loop supply chain follows circular economy principles. Materials and products are reused, repaired, remanufactured, or recycled to minimize waste and pollution. This promotes resource efficiency and sustainability. The key difference is that closed-loop supply chains keep resources in use for as long as possible, extracting the maximum value from them while in use, then recovering and regenerating products and materials at the end of their service life. This circular approach stands in contrast to the linear take-make-waste model of the traditional supply chain. The circular economy diagram on this slide illustrates how renewable energy sources can be integrated into a sustainable, cyclical system of resource use and reuse. Solar panels can be recycled to recover valuable materials like silicon and aluminum, extending their lifespan and reducing waste. Wind turbine blades, often made from fiberglass, can be recycled or repurposed for other applications, minimizing landfill waste. Hydroelectric dams can be designed for longevity and incorporate circular economy principles, such as using recycled materials and minimizing environmental impact. Bioenergy sources like wood and agricultural waste can be used in a circular manner, generating energy and creating valuable byproducts for use in other industries. The goal is to create a closed-loop system where resources are continuously cycled and reused, minimizing waste and environmental impact. Traditional water management is a linear approach that relies on extracting water from natural sources, using it and then discharging it as wastewater. This often leads to water scarcity, pollution, and environmental degradation, as there is little focus on reuse or recycling. Circular water systems, on the other hand, prioritize water conservation, reuse, and recycling to minimize water consumption and pollution. Circular systems aim to create closed-loop systems where water is used and reused efficiently, reducing the reliance on external sources. Technologies like rainwater harvesting, greywater recycling, and wastewater treatment are used to promote resource efficiency and sustainability in circular water systems. Traditional food systems often involve long supply chains, reliance on fossil fuels, and significant food waste, which can contribute to environmental degradation, resource depletion, and social inequalities. In contrast, circular food systems aim to minimize waste, maximize resource efficiency, and promote sustainable food production through local production, regenerative agriculture, and closed-loop systems. Circular food systems can contribute to increased food security, reduced environmental impact, and enhanced community resilience. The key differences between traditional and circular food systems are the focus on waste reduction, resource efficiency, and sustainable production methods in the circular model. The linear model of plastics production relies on virgin resources, leading to depletion and pollution. Most plastic packaging ends up in landfills or contaminates the environment. Circular approaches prioritize reuse, recycling, and bio-based materials. They minimize waste and pollution, while promoting resource efficiency and sustainable packaging. Recycled plastics, biodegradable materials, and reusable packaging are all key components of a circular plastics economy. This slide provides an overview of the differences between the linear and circular models of plastics production and use. It highlights the environmental issues with the linear model and the benefits of transitioning to a more circular approach. The traditional linear model of electronics production relies on virgin materials, leading to rapid obsolescence and high e-waste generation. This linear system contributes to environmental pollution, resource depletion, and social issues related to mining and manufacturing. In contrast, a circular approach prioritizes extended product life cycles, reuse, repair, and responsible recycling. This circular model promotes resource efficiency, reduces environmental impact, and fosters sustainable practices in the electronics industry. The key difference is shifting from a linear, wasteful system to a circular, resource-efficient one that minimizes environmental harm. Traditional construction is a linear model that relies on virgin resources, leading to waste, pollution, and environmental degradation. It involves high resource consumption, significant waste generation, and limited material reuse and recycling. Circular construction, on the other hand, prioritizes reuse, recycling, and resource efficiency to minimize waste and reduce environmental impact. Key principles of circular construction include reduce, reuse, recycle, deconstruction, and material recovery, and the use of sustainable building materials. Transitioning to a circular approach in the built environment can promote more sustainable development and help address the environmental challenges we face. The linear textile production model relies on virgin resources, leading to high resource depletion and waste. This traditional system often uses harmful chemicals and generates significant pollution. In contrast, the circular textile model emphasizes reuse, recycling, and sustainable materials. The circular approach aims to minimize waste, reduce environmental impact, and promote ethical labor practices. This shift from a linear to a circular model is crucial for creating a more sustainable fashion industry. Circular mobility is a new approach to transportation that aims to be more sustainable and efficient compared to traditional car-centric models. The traditional model relies heavily on private car ownership and fossil fuels, leading to issues like high carbon emissions, traffic congestion, and limited access for those without vehicles. In contrast, circular mobility prioritizes shared mobility, sustainable vehicles, and efficient infrastructure. This helps promote resource efficiency, reduce pollution, and enhance urban livability. Key elements of circular mobility include electric vehicles and shared mobility services, active transportation like walking and cycling, and efficient public transportation systems. The goal is to move away from the traditional linear model of transportation towards a more circular, sustainable, and inclusive approach. The linear economy, based on a take-make-waste model, often undermines the sustainable development goals by depleting natural resources and generating pollution. This linear approach contributes to major global challenges like climate change, biodiversity loss, and social inequalities. In contrast, the circular economy aligns with the sustainable development goals by promoting resource efficiency and reducing waste. The circular economy fosters sustainable production and consumption patterns, leading to a more equitable and resilient future for all. By transitioning from a linear to a circular model, we can make significant progress towards achieving the sustainable development goals. The linear economy's heavy reliance on fossil fuels contributes significantly to greenhouse gas emissions and climate change. In contrast, the circular economy promotes resource efficiency, reduces waste, and minimizes dependence on fossil fuels. By extending product life cycles using renewable energy and focusing on reuse, repair, and recycling, the circular economy lowers carbon emissions and helps mitigate climate change. The circular economy's sustainable practices reduce the need for new resources, further decreasing the carbon intensity of production and consumption. The traditional linear economy has often been measured by economic indicators like GDP, without fully accounting for environmental impact or resource depletion. These linear metrics can be limited in evaluating the sustainability and circularity of a system. Circular economy metrics, on the other hand, assess resource efficiency, waste reduction, and material recovery to evaluate performance. Key circular economy indicators include resource consumption, recycling rates, product lifespan, and circularity scorecards. These metrics provide a more comprehensive view of how effectively a system is transitioning towards a circular model. Circular economy is a sustainable approach that aims to keep materials and products in use for as long as possible, minimizing waste. Businesses can implement various strategies to transition to a circular economy, including product design for circularity, designing products to be durable, reparable, and easy to disassemble, allowing for better material recovery at the end of the product's life. Closed-loop supply chains, developing supply chains where materials are reused, recycled, or repurposed, reducing waste generation. Product-as-a-service models, shifting from selling products to providing services that leverage shared resources, minimizing ownership. Collaboration and partnerships, engaging with suppliers, customers, and other stakeholders to create a circular economy ecosystem. These strategies can help businesses transition to a more sustainable, circular model that benefits the environment and their bottom line. The circular product design concept we're exploring today focuses on 4 key principles: durability, repairability, recyclability, and reuse. Durability is about designing products that last longer, reducing the need for replacements and minimizing waste. Repairability means making products easy to fix, extending their lifespan and reducing the need for new materials. Recyclability involves using recyclable materials and designing for easy disassembly, maximizing material recovery at the end of a product's life. Reuse is about designing products that can be repurposed for different uses or as components in other products. Integrating these circular design principles can help us create more sustainable, environmentally friendly products. The circular economy requires collaboration and partnerships across different stakeholders. Governments and industry need to work together on policies and initiatives that promote circular practices. Industry clusters can cooperate to share resources, expertise, and best practices. Research and development on innovative circular technologies and materials requires collaboration between companies, universities, and research institutions. Nonprofit organizations play a crucial role in raising awareness and advocating for circular economy initiatives. Bringing these diverse groups together is key to transitioning to a more sustainable circular economic model. The linear take, make, dispose model of consumer behavior has led to excessive waste and resource depletion. Consumers today are increasingly prioritizing sustainability, durability, and product lifespan. This shift towards a reduce, reuse, recycle circular economy model is encouraging more mindful consumption and responsible disposal. Highlight how consumers are valuing sustainability over just low prices and convenience. Emphasize the importance of this behavioral shift in transitioning to a more circular and environmentally friendly economic model. The traditional regulatory approach has focused on managing pollution and waste after production, with limited effectiveness in promoting sustainability. These traditional approaches often relied on command and control measures, using fines and penalties to try to drive change. In contrast, circular economy policies aim to promote sustainable production and consumption through incentives, standards, and extended producer responsibility. The goal is to encourage innovation, resource efficiency, and waste reduction across the entire product life cycle. Policymakers are shifting towards a more proactive, systems-level approach to drive the transition to a circular economy. The traditional regulatory approach has focused on managing pollution and waste after production, with limited effectiveness in promoting sustainability. These traditional approaches often relied on command and control measures, using fines and penalties to try to drive change. In contrast, circular economy policies aim to promote sustainable production and consumption through incentives, standards, and extended producer responsibility. The goal is to encourage innovation, resource efficiency, and waste reduction across the entire product life cycle. Policymakers are shifting towards a more proactive, systems-level approach to drive the transition to a circular economy. The transition to a circular economy requires a shift in how we approach financing. Traditional financing models often prioritize short-term profits over long-term sustainability. This can lead to unsustainable practices and resource depletion. Circular economy financing focuses on creating long-term value by investing in projects that reduce waste, promote resource efficiency, and have positive social and environmental impacts. This approach aligns with the principles of the circular economy, which aims to keep resources in use for as long as possible and eliminate waste. By adopting circular economy financing, we can support the development of more sustainable business models and drive the transition to a more circular and resilient economy. The traditional development model in many developing nations has led to resource depletion, pollution, and waste management challenges, causing environmental degradation and social inequalities. In contrast, the circular economy approach offers a more sustainable path forward. It promotes resource efficiency, reduces waste, and fosters local economic growth. This circular economy model can help alleviate poverty, improve livelihoods, and protect the environment in the developing world. The key is to shift away from the linear take-make-waste approach and towards a circular system that reuses, recycles, and regenerates resources. Implementing circular economy principles can create new economic opportunities, green jobs, and more equitable development in the developing context. The traditional approach to city planning has often been focused on economic growth and efficiency, without adequately considering environmental and social factors. This can lead to issues like resource depletion, pollution, and social inequalities within the urban environment. In contrast, the circular city planning model prioritizes resource efficiency, waste reduction, and sustainable practices. This approach promotes a more equitable and resilient urban environment, ultimately improving the quality of life for all residents. The key difference is the emphasis on closing resource loops and minimizing waste, rather than a linear take-make-waste model. The circular economy and circular island concept represents a vision for a sustainable, regenerative, and ecologically balanced future. This slide highlights 4 key elements of the circular island. Renewable energy, harnessing wind, solar, and other renewable sources to generate clean, sustainable power. Water stewardship, implementing rainwater harvesting, greywater recycling, and efficient water management systems to conserve and reuse this precious resource. Circular food systems, promoting local food production, regenerative agriculture, and composting to create a closed-loop food system. Waste management, minimizing waste generation and maximizing reuse, recycling, and composting to eliminate waste. Together, these elements create an integrated, self-sustaining ecosystem that is in harmony with the natural environment. Traditional farming practices often deplete soil nutrients, leading to increased use of chemical fertilizers and pesticides. Circular farming, on the other hand, focuses on closed-loop systems and resource efficiency. Circular farms integrate livestock and use compost to restore soil health, minimizing waste and maintaining soil fertility. This circular approach contrasts with the linear model of traditional farming. Traditional factories often operate in a linear manner, consuming resources and generating waste. This model prioritizes production efficiency at the expense of sustainability. In contrast, circular factories adopt a closed-loop approach, reducing waste, reusing materials, and promoting resource efficiency. They prioritize environmental sustainability and social responsibility. The transition from traditional to circular factories is a key aspect of the circular economy, which aims to design out waste and pollution, keep products and materials in use, and regenerate natural systems. Circular factories represent a more sustainable and responsible model of industrial production, with the potential to significantly reduce the environmental impact of manufacturing. The traditional linear economy is unsustainable, relying heavily on extraction, production, and disposal, leading to resource depletion, pollution, and environmental damage. The circular economy offers a more sustainable alternative, focusing on resource efficiency, waste reduction, and product longevity. However, implementing the circular economy faces significant barriers, such as infrastructure limitations, consumer behavior, and regulatory frameworks. These barriers must be overcome in order to successfully transition to a more sustainable circular economic model. We will explore some of the key barriers and discuss strategies for addressing them in the following slides. The COVID-19 pandemic has exposed the vulnerabilities of our current linear economic model. This model, based on take-make waste, relies heavily on global supply chains and single-use products. When the pandemic disrupted these supply chains, it led to shortages and increased waste as orders were cancelled. In contrast, the circular economy demonstrated resilience during this time. Circular models were able to adapt to changing consumer needs and promote local production. Practices like repairs, reuse, and repurposing helped businesses and communities maintain essential services. The circular economy's focus on resource efficiency and closed-loop systems reduced its dependence on global supply chains. This shows the advantages of transitioning to a more circular, sustainable economic model. The circular economy presents new job opportunities in areas like waste management, recycling, and repair. These are sustainable jobs that support environmental goals. As the economy shifts, workers will need to acquire new skills through reskilling and upskilling to adapt to circular economy practices and technological advancements. Educational institutions and training programs play a crucial role in developing a skilled workforce equipped for the circular economy of the future. This transition requires investment in building the right knowledge and capabilities among workers to support the circular economy. Traditional education has often focused on linear models, emphasizing consumption and waste, and lacking real-world applications for sustainable practices. Circular economy education, on the other hand, incorporates principles of resource efficiency, waste reduction, and sustainable practices. This approach promotes hands-on learning, critical thinking, and problem-solving skills to address environmental and social challenges. By shifting the focus to circular economy principles, we can better prepare students for the future and empower them to be agents of positive change. Traditional urban planning has focused primarily on economic growth and efficiency, often neglecting environmental and social considerations. This model can lead to issues like resource depletion, pollution, and social inequalities within cities. In contrast, circular urban planning prioritizes resource efficiency, waste reduction, and sustainable practices. This model promotes a more equitable and resilient urban environment, ultimately improving the quality of life for all residents. The key difference is the shift from a linear take-make-waste approach to a circular model that keeps resources in use for as long as possible. The traditional linear energy model is based on extraction, production, and consumption, often relying on fossil fuels and generating waste. In contrast, the circular energy model prioritizes renewable sources, reuse, and efficient consumption. This circular approach reduces pollution and waste, and promotes resource efficiency. The key difference is the shift from a linear, wasteful system to a closed-loop, sustainable energy model. The circular economy aims to keep resources in use for as long as possible, extract the maximum value from them, and then recover and regenerate products and materials at the end of their service life. Transitioning to a circular energy system is crucial for a more sustainable future, as it reduces environmental impact and supports the efficient use of limited resources. The linear manufacturing model is the traditional approach, focused on production efficiency but often creating waste and depleting resources. In contrast, circular manufacturing promotes sustainability by creating closed-loop systems where materials are reused, recycled, or repurposed, minimizing environmental impact. This circular model aims to achieve resource efficiency and reduce waste, in contrast to the linear model's focus on production at the expense of sustainability. The key difference is the shift from a linear, wasteful approach to a circular, closed-loop system that keeps materials in use for as long as possible. The traditional mobility model of private car ownership and fossil fuels has led to significant challenges, including traffic congestion, air pollution, and resource depletion. In contrast, the circular mobility approach prioritizes shared mobility, sustainable vehicles, and efficient infrastructure. This approach promotes resource efficiency, reduces pollution, and enhances urban livability. The key difference between traditional and circular mobility is the focus on sustainability and shared resources rather than individual ownership and fossil fuels. Transitioning to a circular mobility model can help address the environmental and societal issues associated with the current transportation system. The traditional food system is linear, relying on intensive agriculture that depletes soil and uses harmful chemicals. In contrast, circular food systems prioritize resource efficiency through local production, composting, and sustainable farming practices. This shift towards a circular economy for food can help address the environmental challenges of the current linear model. By closing resource loops and minimizing waste, circular food systems offer a more sustainable path forward. The key differences between traditional and circular food systems are the focus on resource efficiency and environmental impact. The traditional linear waste management model of disposal in landfills is unsustainable. It generates pollution, depletes resources, and damages the environment. In contrast, the circular waste management approach prioritizes reuse, recycling, and composting. This circular model reduces waste, recovers valuable materials, and minimizes environmental impact. Transitioning from a linear to a circular waste management system is crucial for a more sustainable future. We'll explore the key differences between these two approaches and discuss the benefits of adopting a circular economy mindset for waste management. The traditional built environment relies heavily on virgin materials and linear processes, leading to significant resource depletion and waste. Traditional construction methods often prioritize speed and cost efficiency over long-term sustainability, resulting in buildings with limited lifespans that require costly demolition and rebuilding. In contrast, the circular built environment promotes resource efficiency, waste reduction, and the use of sustainable materials. Circular principles focus on extending the lifespan of buildings through design for disassembly, reuse, and recycling, reducing the need for virgin resources and minimizing environmental impact. Circular construction emphasizes the use of renewable and recycled materials, fostering a more sustainable and resilient built environment. The linear global economy is unsustainable, relying on continuous resource extraction and consumption, leading to waste, pollution, and environmental damage. In contrast, the circular global economy promotes resource efficiency and waste reduction, fostering sustainable production and consumption. The circular economy creates new economic opportunities and enhances resilience, making it a more sustainable model for the future. This slide sets the stage by contrasting the linear and circular economic models, highlighting the key differences and the need to transition towards a more sustainable circular approach. The circular economy is a sustainable model that aims to minimize waste and keep resources in use for as long as possible. We all have a role to play in embracing the circular economy and driving change. First, we can reduce our consumption by making conscious choices to buy durable, reparable products, and prioritize reuse and sharing. Second, we can support circular businesses, those that prioritize sustainable practices and offer products designed for longevity and circularity. Third, we can advocate for policy change by urging policymakers to implement regulations that promote circular economy initiatives and incentivize sustainable practices. Finally, we can educate and inspire others by sharing our knowledge about the circular economy and encouraging them to adopt sustainable practices. Together, we can contribute to a more sustainable future by embracing the principles of the circular economy.